So this was part 3 of this 3-part series on the overhaul for the 8L90. And in this video, we cover the valve body. So now at this point, we're going to go through and do a deep dive into this valve body. And we're going to study how this thing works. We're going to take it apart, look at all the different valves. We're going to do some measurements, some vacuum tests on these different valve body bores to see if any of them are worn out. In my opinion, this is probably the main area of focus as far as this transmission is concerned, as far as the durability and the longevity of this transmission. So there are already some kits available. Sonnax makes individual valves, some tooling to repair some of this, and they also make a couple zip kits. The zip kits are designed as drop-in valves. You don't have to do any reaming or drilling or anything like that. And Transgo, they provide a couple kits. They've got a tool kit, and then they've got these dampeners, these solenoid accumulators, if you will. And also, and we'll look at those, they also have a shuttle valve, part of the pressure regulator valve circuit. They use a shuttle valve in there, and they got a repair for it. So we're going to go through and study this thing a little bit, and then we're going to take it apart, do those measurements, take a look at these upgrades, maybe perform a few of them, and then put it back together. Doing a quick peek at this valve body, you can see a few things I've done here. I've labeled these solenoids with what they do. So this one right here is in charge of the torque converter clutch. This one here is in charge of the C4 clutch, C3 clutch, C5 clutch, C1 clutch, C2 clutch. This is the line pressure solenoid. This right here is the default solenoid, on-off type solenoid. And that solenoid right there is what they call the reverse boost solenoid. And all these solenoids, except for these two, are pulse width modulated. So they will vary the amount of amperage through it, and that will end up shuttling a valve or moving a valve to output a variable amount of pressure. As we mentioned earlier, this is the oil pump, and we'll take it apart and take a peek at it. This is an accumulator that's in the end of this portion of the valve body. And we're going to go ahead and take this apart. So I'm going to go ahead and mention that this valve body right here is not the valve body that goes into this transmission that I'm taking apart in this whole video series. I use this valve body because it shows way more wear. I've already taken both these valve bodies apart, cleaned them up, and so forth. And this valve body came out of a different unit. It had way more wear in it than the one that we were going through as far as this overhaul is concerned. The overhaul transmission's valve body, remember, it just broke that oil pump sprocket, so it really didn't cause that much damage. It's probably a low mileage failure. I don't know, it was a core. But this one here definitely showed some wear, and this transmission, it had a burnt up C3 clutch, so possibly the fault lied in the valve body. Maybe when we go through some of these circuits, we might be able to find the root cause for that C3 failure. That would be nice. It's always good to note where your check balls are, and you can see here I've got these 3 check balls. These are 1/4 inch check balls, and they're provided in the kit. So I'm going to mention again that this is the valve body for a separate unit that does not use that pulse accumulator. These plastic check balls, GM uses these in quite a few of their transmissions, and they have a tendency of shrinking over time, so they're not things that you probably should ever reuse. You would just definitely want to replace them. I'm going to go ahead and take the rest of this valve body off, but these are the solenoid accumulators. And you could see on this unit, these solenoid accumulators, see how shiny it is right there. They're definitely wearing into the piston pretty good. The anodizing is wearing off. So all the bolts that were holding this plate on had 8mm heads, all the same length. All these other bolts that held the valve body halves together used the 7mm heads, so it's easy to distinguish the two apart, so you won't get too confused trying to figure out what bolt goes where. I'm going to go ahead and pull these accumulator pistons out with their springs, put them off to the side. Might be worth noting their location, just so if you find out one of these are bad, you'll be able to determine if that was the reason for the root cause failure. Now when we split these two valve body halves, if we keep the spacer plate with the valve body half, we can keep the check balls from falling out on us. If it's never been apart before, it might have a little Christmas tree here and here, kind of holding that valve body spacer plate on there. So the OE kit comes with new spacer plates with the gaskets bonded to it. But if you got the Precision kit, they actually come with paper gaskets, so you can scrape it off the old paper gasket and put a new paper gasket on it if you decide to go that route. Or you could just order these spacer plates independently. So we're going to go ahead and pull out the rest of these check balls. This one right here was not used in the valve body that I'm taking apart here. And I'll put these check balls off to the side. This is a good time to take a picture with your smartphone if you have to. So hopefully you won't forget where they went. There are a couple variations. And the Sonnax information, when you go to their website, the Sonnax information has a pretty good picture and description of where the check balls are supposed to go. So if you get them mixed up, just refer to that. That might help. So now what we're going to do is we're going to pull all these valves out of the valve body, study them, figure out how they work, what they do, put them back together, and then we'll vacuum check it. Okay, now I've gone through and I've stripped down this valve body, and I can go through and clean it up, which I already did, but that's what you'd be doing at this point. Blowing it out real well and putting it back together so we can go through and do a vacuum test on it. If everything checks out good, you're good to go. If not, you're going to go through and address some of these valves and some of this wear that's going on in the valve body. Now, right now, from the dealer, pretty much everybody is just purchasing a new valve body. You can't get these solenoids individually or anything like that. So you might be limited on the repair that you can do depending on what failure you have. But there are companies like Sonnax and Transgo that are dealing with some of these individual parts of this valve body, and we'll look at that and see if there's some kind of aftermarket fixes that we can do or modifications to prevent the failures that are kind of known to this unit. So right here, that's that PUN number. This is the number that you would enter into the scan tool to teach the TCM what the flow characteristics of the valve body and the solenoids are at. Looking at these solenoid accumulators, you can see the wear. The shiny parts are the wear. The darker parts are the anodizing, and the anodizing is wearing off on these. So you can see these little accumulators are being side loaded or something because they wear more on one side than they do the other. Some of these solenoids are normally low, which means when these solenoids are turned off, they don't pass any pressure. And you can see this one here, the part number ends with 2280. This one here, the part number ends in 2281. There's another 2280, normally low, a normally high that ends in 2282, another normally high that ends in 2282, and a normally low that ends in 2280, normally high that ends in 2282. When you look at these valves, you can see there's a hole drilled in between these two spools, and that hole opens up to the end of the valve, so pressure that gets in through that hole will come out towards the end on the spring end of that valve. So it's a way for pressure that's in this spool area to find its way to what I would call the reaction side or the spring side of the valve. Notice this one has a notch cut on the end. That helps identify what type of valve this is. This valve isn't as dark as the other valves, but still has a hole between the spools that ends up on the spring end of the valve. This valve is a different diameter, though, than the other valves. This accumulator right here is for the 13567 clutch, which is also the C3 clutch. The small valve right here is the 12345 boost valve. And this one with the hefty spring, that's the converter feed limit valve. So I'm going to go back together with this valve body, but when I do, I'm also going to take advantage of the fact that I've got these Sonnax kits and these Transgo kits, and I'm going to take a look at what they're doing here. This Sonnax kit right here addresses the solenoid or lower valve body, whatever you want to call it, by dealing with the torque converter clutch valve, which this could also be used as one of the shift valves. And so what they've done is they've provided a valve with a scarf cut seal and a new spring. And I'm going to compare it to the original valve and see what's different. And they also have a converter feed limit valve assembly. They're going to replace this big old honker with their setup. It looks scared, doesn't it? That looks like Groot. Does that look like baby Groot? Maybe aluminum Groot? So this valve living in that bore, pressure is going to come in through that tiny little hole, get to the end of this valve, and push off. And it'll move this valve over until this land blocks off the passageway between the converter feed and line pressure. And this dimension right here, from where that spring sits to where the little bracket that holds it in, that dimension is the amount of force that that spring is going to exert. So if I measure that, I'm going to say it's about 155 thousandths of an inch. So it's 155 thousandths of an inch, but I'm going to need to subtract the thickness of that little bracket plate, which is 80 thousandths. So using that math, this spring is going to compress to 975 thousandths of an inch, and that amount of force is going to be what's pushing this valve over. I'm going to build up enough pressure across this surface area to overcome that force before it will limit the amount of pressure going to the torque converter. And hope that this thing doesn't shoot out and kill somebody. All right, so my spring is compressed at 18.7, we'll call it 18.75 pounds of force. Now looking at the surface area, the end of this valve is about 353 thousandths of an inch in diameter. So doing the math, this valve, when it's stroked into its regulating position, compressing the spring to about 975 thousandths of an inch, and it's exerting about 18.75 pounds on the end of this valve, it's going to require 191-ish PSI to stroke that valve into that position and cut itself off. So according to my math, which starting to question, and I don't know, this converter feed limit doesn't actually limit it until it's about upwards to 190 PSI. That seems pretty high for a torque converter. But hey, let's see what the Sonnax valve equates to. Maybe that'll shed a little different light. Now the Sonnax valve, as I'm now calling Baby Groot, because it looks like a little Baby Groot, trademark. You can tell that they're replacing any worn out valve body bore with this portion of the valve, and they've built the valve to work within this sleeve out of a higher quality, higher grade aluminum. But the function's still going to be the same, but since my surface areas are going to be so much smaller, they provide their own spring, which is going to have less tension. But it looks like the regulating position on it is going to be right around in that spot right there. It's where it closes itself off. So with their bushing installed, I can still get about an 18 to 20 thousandths feeler gauge between the bushing and my little retainer. So I'll have to take that into consideration when I'm doing this math. So even though there's a little bit of clearance between the retaining plate and this bushing, I don't even know if I really need to take that into consideration, because once pressure's in here, it's probably going to push that sleeve towards that retaining plate. Then it looks like it's going to move this valve to its regulating position, which is about there. So the compressed spring is really going to be from the end of the valve to the edge of this bushing. And that's the measurement that we'll use to figure out how much tension they're putting on this valve. Using my dial caliper and playing tug of war with this thing, pushing it in right about there is when it cuts itself off. I'm right at about 900 thousandths of an inch. It's either 890, between 890 and 900 thousandths. So it looks like at 895 thousandths of an inch, that's its regulating spot. So we're going to go ahead and put this on that spring force gauge, and we're going to see at 895 thousandths how much force this spring can generate and push on the end of this valve. Damn. Okay. It looks like at 895 thousandths, we're right at about 11.5 pounds of force. So doing the math on this converter regulator valve, the surface area right here is 272 thousandths of an inch in diameter. And when you do the math and figure that out, that comes out to be 0.058 thousandths of a square inch. It's pretty small. So of course they had to go through and adjust the spring tension. So when you go through and calculate that surface area, 0.058, divide that into the 11.5 pounds of force that we were getting on the spring when it was in its regulating position, you got 198 psi. So this converter regulator is regulating at about 198 psi, according to my calculations, give or take 100 psi or so. I don't know. No, but yeah, so it looks like they're trying to maintain pretty much the same converter limit pressure that was OE. You know, it's within 5% or so. So that's probably my calculation error right there. So now let's move over to the torque converter regulator valve. The regulator valve is controlled by the solenoid, torque converter clutch solenoid, and this is all part of the zip kit that's dedicated towards the torque converter clutch circuit. You can see what they've done here is they've added a little groove into their valve. If we compare the OE valve to the Sonnax valve, they're the same size, the same diameter, the holes are in the same spot, the spools are in the same spot. One difference up here on the spring side is where the OE spring just kind of rests in this area right here, like that. The Sonnax spring is going to fit inside a little recessed spot to kind of stabilize and support their valve there a little bit. There's a different tension spring, slightly different, longer. It's colored red because that's what they want you to use with the torque converter, and if you're using it in place of one of the clutch regulator valves, you would use a different spring, this white spring. So when this is laying in here, this valve strokes to about 420 thousandths before it cuts off its feed or its supply. So out of curiosity, I want to see how that compared to the Sonnax valve. Now the Sonnax valve spring is different than the OE spring. It's longer, but it's because it sits deeper inside their valve. But since the valve is the same, I decided I would just go ahead and compress this down to the same measurement and just do it with the valve right on top of it and do a comparison. So let's see what that equals out to. So the way that this regulator valve works, and in this case, it's the case of the torque converter clutch solenoid. And the valve is going to be sitting here as such. And in this passage right here is going to be line pressure. This passage is the torque converter clutch. And then this passage is exhaust. So what ends up happening is when they want, right now line pressure can't get anywhere because it can't get past that spool. So what happens now is when the solenoid that lives behind it here, it receives pressure from the basically line pressure, and it's going to deliver that to the end of this valve. And it's going to stroke this valve over, and when we start letting line pressure into the torque converter clutch circuit, that pressure finds its way through that little hole, comes its way to the back of the valve, and works with the spring to return it and close it off to the point where no more pressure can get in. If they want more line pressure, they'll duty cycle the solenoid higher and build more pressure up on this end of the valve, on the solenoid reaction land. That will move the valve over, let more line pressure into the torque converter clutch circuit. That additional pressure will find its way over and help with that, or work with that spring to move that valve closed again. So it's always going to be a competition between the solenoid pressure on one end of the valve and the torque converter clutch pressure that found its way to the other end of the valve, plus whatever that spring is helping it with. So basically these springs are little helper springs. So that basic premise works with all these different regulator valves for all these different clutches. You can see they're all designed the same. So really they're doing the same thing as far as delivering pressure from the solenoid to the end of the valve. The pressure that it lets into the circuit works with the spring to close that circuit off. The more solenoid pressure that they create, the more pressure that'll find its way into that clutch circuit until it can close itself off. So with that Sonnax zip kit, you can see that adding this little Teflon seal to the end of the valve, the solenoid end, that's going to prevent any leakage that occurs from that end. Also, the feedback end, the area where the pressure that they let into the clutch circuit, you can see that they've elongated the surface area. They made it longer. So hopefully if there's any wear on this end of the bore on the valve body, this portion of that Sonnax valve is going to ride in that unused portion of that valve body bore, and it's going to be stabilized and sealed up nice and good. I'm going to put this back together with everything stock to start out with, so that way we can do a vacuum check on it. So for this valve body, I'm actually only going to vacuum test the clutch regulator valve for C3, because you actually, and Sonnax provides, or not provides, but sells a special tool that allows you to vacuum check these. It basically replaces this valve with a dummy valve, and they have it for the different size valves that are in here. And the reason why they do that is because there's that tiny hole that's in there, and if you vacuum check this, vacuum is going to leak out through that hole. But what I'll do is I'll just cut a little strip of electrical tape and wrap it around and cover that hole. But I'm not going to do that on every single one, but I figured I'll go ahead and do it on the C3 because that is the clutch that was failed on this transmission. So the other ones I went ahead and put back together and put in. So you can see that these are the ends, that's the spring end of all these pressure regulator valves. And that's the one that you're either going to want to use their recommended vacuum test tool, or you're going to have to close off that hole. So I'm going to put on the C3 that I'm using, this one right here, I'm going to go through and put a piece of electrical tape on the valve, something you probably don't want to forget to take off when you're done with it. But and then some of these others might have special instructions too. And there's actually also on this converter feed limit valve, there's also a little passageway there that you're supposed to plug off. And then with those accumulators, we can go ahead and place some suction on top of those to see if those are sealing up or leaking. So we're calibrated with our vacuum gauge. We're showing 25 inches and roughly 5 inches. We're going to go through and check all of our accumulators. Start with this one here. Good seal, looks good. Next, that one's low. That one's definitely a bad one. We'll mark it. This one is questionable. Nope, that one's actually really good. This one's a massive leak, only pulling 1 inch. This is definitely a bad one right here. This one's not sealing up very well either. Getting about 5 inches, 11 inches, 15 inches. Both of those are pretty bad. That one's probably pretty good. So good. We got 4 bad ones, 3 good ones. So for a shift valve, we're going to want to plug off that hole. I'm going to use a piece of electrical tape. And hopefully this will do a good enough job to seal that off. Actually seals up pretty good. Got 20 inches on the solenoid side. Got 24 inches on the reaction land on this side. We can go ahead and check our 1365 accumulator while we're here, right through that passage. 24 inches on that, that's a good seal. That's a pass. And our lube regulator valve is going to be that little guy right there. Got about 18 inches. This didn't turn out too bad. I got 18 inches on my lube regulator valve. Now I only checked my C3 regulator valve. Obviously, I'd want to check all of them, but they're all pretty much the tests are the same. And I got some good readings. The solenoid side read real strong. at around 20 inches, and then the reaction land on the end of the valve, that ended up reading pretty high too. It was like 24 inches. And then I went ahead and checked my accumulator here, and that tested strong. I think that was 18 inches, I don't remember, maybe 20 inches. So the only thing I found so far in this valve body were the solenoid accumulators. I found some pretty bad ones, so those would probably be, which I would hope, the root cause failure of this unit right here. So the options that we have for this valve body right here, obviously we have to deal with those solenoid accumulators. Those things are worn out. At least 4 out of the 7 were pretty bad. So Sonnax offers a zip kit that is for the shift valves or the shift quality. So you can see this kit comes with these little end plugs that are going to accept an O-ring. They come with the new accumulator pistons, sleeves for those pistons to ride in, and new little springs. So the concept of this is pretty straightforward. You can see they take this sleeve and slide it into the valve body bore. Then you take a new accumulator piston that's a little smaller, slide that into the sleeve, put a spring in there, then you put an O-ring around one of these little end plugs or these little caps, covers, whatever you want to call them. And the raised part, the part that's sticking up there a little bit, it fits into that sleeve nice and perfect. And then when you have that whole assembly installed in there, it kind of captures that in there nicely. Start with the sleeve, piston, spring, then our plunger with the raised edge facing down towards the sleeve. So Transgo has their procedure for dealing with these solenoid accumulators. It involves mounting this jig assembly to the valve body, and they've got this nice jig. They want you to put this pin in first, kind of seat it down where there's a taper on it, kind of push it down to the taper contacts at the top of the valve body, and then you slide this jig down on it, and then you tighten these wing nuts up, and you've got these big aluminum washers on both sides, so you won't damage their jig or you won't damage the valve body. And then once you have it in place, you pull that tapered pin out. A nice, tight, precision fit there. Whew. And now this serves as a guide to allow a reamer to go in there and remount this bore. It's a carbide tipped reamer. They want you to use a cordless drill and spin it slow and work it into that guide right here. And they want you to also flood it with WD-40 or some kind of reaming fluid. And this is what we're going to use. They want you to continue until it's bottomed out in the bore. And then you're done. Now I did this on a valve body that's already got some of this stuff installed, and obviously I would want to take this completely apart, clean it, flush out all the chips and so forth. I'd want to do this on just a valve body that was stripped down naked, but because I'm going through and trying multiple products here, I elected to keep all these things installed because I was vacuum testing it and so forth. But now I'm going to have to go ahead and take it apart and clean it so I can get those chips out of there. Normally, once you determine that these were sealing poorly, you would go through and ream this stuff out before you even went back and installed any other valves or solenoids. It's a nice fit. So with the Sonnax zip kit that deals with the shift components, I already have my solenoid accumulators installed, and they include a few other things. And this right here is a regulator valve, a clutch regulator valve, and you can either use it with a clutch, the 2, 3, or 4 clutch, C2, 3, or 4, or if you use the red spring, you can use it with the torque converter clutch. But since I already have the torque converter clutch zip kit and I'm installing it, I can use this valve on my C2, 3, or 4. Then we also have one valve where we can replace either C1 or C5. And then I also have this C3 accumulator. And you can see what it does is it's It's a nice anodized accumulator, and they have an O-ring groove here. And they give you an extra O-ring, but you put an O-ring in there with the spring, and then they give you a new washer, and you reuse the clip that holds everything in place. So I might as well go ahead and use these parts in here, and since my C3 clutch was the big failure item, and I know these things air tested perfectly fine, there's nothing wrong with them, so I'll go ahead and use the pressure regulator valve that could be used in either the torque converter clutch spot or it can be used in the C2, C3, or C4 spot. So I'm going to use it here in the C3 spot, since that was my failure in this transmission. So with the white spring and the Teflon seal installed, we'll go ahead and put that into the C3 spot and install our solenoid. And because I haven't installed it yet, I'm going to go ahead and install the torque converter clutch valve and spring. And you have your Teflon seal installed in there, but you also use the red spring with the torque converter clutch. Now this valve I can use in the C1 or the C5 spot. Neither of those had an issue, but I'm going to go ahead and install it since I've got it included in the kit. And I'll just go ahead and put it in the C5 spot. For the solenoid body, I'm going to change the C3 accumulator. Even though it air tested out perfectly fine, like I said, since I have this kit, I might as well do it. Sonnax has you roll the accumulator on a bench to help size that O-ring into its groove. That might help installation. And they provide a washer to use in place of the original cover. But you reuse the snap ring. I'm going to go ahead and change out this converter relief valve. That was part of the zip kit for the torque converter clutch. Take out the death spring and replace this whole assembly with the old baby Groot. Survived. All right, there we have it. On this solenoid body, I'm pretty much done. Just got to put the check balls in and put the valve body bolts in, and this side's done. So let's move over to the upper valve body half and see what we got to do there. This is where you can put those little Christmas trees, if you have those, to hold that spacer plate in place. And now we're going to go through the upper valve body. We're going to start by just completely disassembling it, cleaning it, which I already did, and then we'll look at what these valves do. While we're at this point, we'll go ahead and take our oil pump apart. This is the thick pump gasket. There's a little gutter. And here's the oil pump. And these are parts that are included in the kit. These parts are idiot-proof, at least that I've discovered. They won't let you put it together wrong. Appears they made it idiot-proof. If you put this in wrong, the passageways won't line up properly. And it won't fit into the valve body. So once again, I think it's pretty idiot-proof. But if there's a way to screw it up, I can do it. Now looking at these valves and the valve body, we'll go through and identify a couple of these. So the valves that operate on this side, the four valves that are on this side of the valve body. This one right here is kind of an interesting valve. This is basically, and if you look at the hydraulic schematics, it'll be listed as the exhaust backfill, and it's got a really soft spring. And the fluid pressure that they put behind the clutches is regulated by that valve. And it just basically, it takes AFL pressure through an orifice, and then on the other side of that orifice, this spring and this ball exists. And so this will keep the pressure really low, but it'll keep the circuits filled up on the back sides of the hydraulic pistons. And these two valves right here deal with the torque converter clutch. This is the torque converter clutch control valve. And then this valve, kind of in the middle there, that is the lube regulator valve. And if you notice, the lube regulator valve and the torque converter clutch control valve have this end plug, and the end plug has this little snout, and the snout goes in toward the spring on those. On the other side of the valve body, we've got a few valves. I did not take out the line pressure blow-off valve. I didn't want to die and the spring shoot out and kill me. So this right here is our default valve that'll be controlled. And if you take a look with this default valve, it actually has the same end plug, but in this case, the snout faces outward, away from the spring. And then this is the ever so popular and common AFL valve, actuator feed limit. So this is the valve that's responsible for feeding all the solenoids in the transmission, providing the pressure. Actually, not all of them, but most of them. And then this valve set up right here is the line pressure regulator valve with a what they call shuttle valve. And in the shuttle valve, there is a valve within the shuttle valve. And then the spring exists on the back side. Now, for some reason, this right here apparently gets misinstalled quite frequently, where people are putting this shuttle valve in backwards, or people are putting the spring in the wrong spot. So make sure you put these things back together the way you took them apart. And we're going to go through and look at the Sonnax modifications. There's a few things that they address with their zip kit. One is they replace these end plugs with O-ringed end plugs so they don't leak. And we're going to put this back together. We're going to do a vacuum check on it just like we did the other half of the valve body. And we're also going to go through and look at some aftermarket kit parts. Like Transgo, for example, they make a replacement for this. They've got their own shuttle valve that's machined in case this one wears out. And Sonnax also makes a shuttle valve and a drop-in pressure regulator valve. And also Sonnax provides a few of these end plugs in their O-rings, so that way you don't leak anything past these end plugs. So we'll go through and do a vacuum test, see how this thing fares. Then we'll go ahead and install those modifications and take a look to see if they change anything. And if they don't, put it all back together and be done with it. Now looking at that exhaust backfill circuit that they have a hole in there that's about 290 thousandths of an inch in diameter, maybe a little smaller. And the pressure, or this check ball seats up against that hole in there. And the pressure that finds its way through that hole is AFL pressure. It pushes that ball off of its seat and leaks out after that. And the AFL is fed through an orifice, and then this circuit right here is after that orifice. So it basically is regulating anything beyond that orifice to a pretty low pressure. So I was curious what that pressure was. So at the depth that that ball sits in there, which is at about 1 inch, 220 thousandths from this edge, and then from when we put that spring in there and that clip, it compresses that spring to about 920 thousandths, which is not that much. So I went and compressed that spring to 920 thousandths of an inch. And as you can see, if there's not too much glare, it's about 1/2 pound of force at 920 thousandths of an inch. So when we do the math and we take that 290 thousandths hole and we figure out the surface area of that, which is the pi times the radius squared. And that ends up being a pretty small hole, pretty small surface area. It is 0.066 square inches. And when we divide that into the 1/2 pound of force that's up against that spring, we see that that circuit only requires like 8 psi to push that ball off of its seat and start regulating the pressure down. So really, that backfill circuit only has about 8 pounds of pressure in it. So in case you're wondering, when you're looking at a hydraulic schematic and you see that listed as exhaust backfill, that's only about 8 psi in there. The way this pressure regulator valve works, there's two actually inputs and outputs to the oil pump. So line pressure is present to 2 different lands. And when there's enough pressure on this side actually being fed through the shuttle valve, through that tiny little hole right there, that pressure is going to work up against the end of this valve. The little the little plunger in our shuttle valve is going to work up against the end of that valve, and it's going to overcome the tension of this spring and whatever solenoid pressure ends up on this side. So the line pressure that it feeds into the transmission finds its way through the shuttle valve to this plunger, and that overcomes the tension of the spring plus solenoid pressure to move this valve over to the point where it releases that pressure into what they call a bypass, but that's just basically the inlet to the oil pump, and that effectively regulates it. So if this was not receiving the pressure, I mean really all that line pressure is just working across this surface area on the end, if this hole was plugged or if this bore was worn out, there would not be enough pressure, and there would not be enough pressure to overcome the spring and the solenoid pressure, and this thing would always be continuously building pressure higher and higher and higher. So when this shuttle valve wears out, you actually end up with high line pressure because there's nothing to overcome the solenoid and spring pressure to move the valve to its point where it's regulating. Okay, going through and testing, we've got our calibration set at 25 and 5. And the first valve that we're going to check here is the torque converter control valve. Pretty good, at least 19 inches. That's 16 inches of vacuum there. Still probably not too bad. I guess about 18 or 19 on that. The end of this pressure regulator valve lineup, part where the solenoid pressure works against. Really good there, over 20. And this is actually a torque converter clutch feed circuit, about 14. So here we could check the shuttle valve, see how well it's sealing. It's a little low, looks like 13, maybe 14. This is the end of that pressure regulator valve. It's about 17 inches. So check the end plugs. It's actually 20 inches is not too bad there. More on that lube regulator valve. Good at 20 inches. Good seal on that lube regulator valve there. Another good seal. So that lube regulator valve checks out really well. It's a torque converter clutch valve right here. In the end of that torque converter clutch valve, we're at 18 inches of vacuum. The other end, 23 or 24 inches of vacuum. Part of that default override valve, there's a few circuits to check. They want you to test basically these two circuits together. And then in this passageway, 20 inches, it looks good. And this passageway right here we'll check next. 16 inches of vacuum. That passage right there. 16 as well. Good strong 23 inches on the end of the default override valve. Our good old trusty actuator feed limit valve. Testing strong on that end. And this passageway right here. 20 inches of vacuum on that. So this all checks out very well. The only suspect would probably be so this checks out fairly well. The only suspect one would be this shuttle valve, where I'm getting about 13 to 14 inches of vacuum. Luckily enough, that gets addressed in the Sonnax kit, and that also gets addressed in the Transgo kit. So continuing on with these kits and these upgrades, let's see what some of the things that we can do with this transmission. Well, the first thing to mention is we could put these little O-ringed end plugs in there. And there's a few locations in this upper valve body where we can go through and upgrade those with that. The O-rings kind of prevent some of the leakage that might occur from around the normal plug and the bore. And then these are 3 of the shuttle valves that we have that work with the pressure regulator valve. And this one here on the far left is the Sonnax valve. They use an aluminum bushing and aluminum anodized shuttle valve. The one in the middle is the GM valve, and it also uses an aluminum bushing with an aluminum shuttle valve. And this one on this end is the Transgo valve, and it's an aluminum bushing, but it's a steel valve. So it's a little different as far as that. Now they all have the same diameter. They're all 325 thousandths of an inch thick. So they're not doing anything with modifying any of the pressure that's going to the end of the pressure regulator valve through that shuttle valve. But if you look close here, this middle valve is the OE valve, and it looks like it has a smaller orifice drilled in it than the Sonnax and the Transgo. It looks slightly smaller visibly. I don't know what the difference is, but it looks a little bit smaller, so it's probably, they oversize that. My guess is to deal with any potential future leakage that might occur between the shuttle valve and the bushing on the inside. If you got leakage between that valve and the bushing, and that leak approaches the size or gets bigger than that hole, that feed hole, you're not going to be able to build up any pressure or force on the shuttle valve, and that is what ends up pushing on the end of the regulator valve to move that valve to regulate pressure. So looking at how this valve works, we've got a spring on this end, and we have these different passageways. Solenoid pressure, line pressure solenoid pressure is going to find its way into this passage and work with the spring to return this valve to close off the bypass or the fluid release that where basically it regulates the pressure in the transmission. This is going to be converter feed in this passageway here. Then these 2 passages are line. That's bypass. This passage right here is where fluid goes once we reach our regulating pressure. Then we have line pressure again in this passage here. And this is bypass again. And then we have in this passageway right here is the fluid pressure that finds its way to the shuttle valve. That shuttle valve will live in there in like that position, so the fluid that finds its way into this passage will find its way through this recess and into that hole feeding that shuttle valve, which will push that valve up against the bottom of this. Looking at the difference between the OE valve and the Sonnax valve, you can see that the spring is different, and then they've added some surface area to the end of this valve compared to the OE valve. So if there's any wear on this end of the valve in the bore, it's going to be addressed by this additional material that they have at the end of that pressure regulator valve. Other than that, it looks like these 2 size-wise are pretty much identical. Now the springs are different, so we're going to look to see if the tension of the spring changed anything. So I think I got this into its regulating position, or pretty close. This is the solenoid passageway here that's going to be working on the end of this pressure regulator valve to move this valve into its regulating position. This is converter feed right here, and line pressure would exist in these 2 passages. So you can see line pressure has its way of getting into the torque converter feed. This chamfer on this valve right here feeds line pressure into the bypass section once we are at its regulating position. And if you look, this one is kind of in that valve body land right there. And we also have line on this passage right here. And you can see it's more open, feeding into the bypass. So there's 2 bypasses, this portion and this portion, and there's two line pressure feeds, this portion here and this portion there. So it looks like this one allows it to bypass first, and then that one, if it strokes further, will bypass second. And right here in this passageway, that feeds the shuttle valve. So the shuttle valve that we have here on the end, when line pressure finds its way into that section, it's going to work on the end of that shuttle valve and move this valve over and eventually get it to the point where these passageways will allow line pressure to dump into the bypass and effectively regulate the pressure. So what I want to do to figure out these springs are the same between the OE valve and the Sonnax valve is I want to measure this dimension right here. We'll compare the force of the spring between the OE valve and the Sonnax valve. These springs determine the minimum amount of line pressure that the pump generates. Basically, we know that these springs are constant, they're always going to be there, so the shuttle valve, the line pressure that finds its way to the shuttle valve to compress that spring, it always has to overcome that spring, and always has to overcome about 1.9 pounds of force before it can start regulating. And since we know the surface area of the shuttle valve is 325 thousandths of an inch, we can calculate the surface area and divide that surface area into the amount of force that our spring produces at its regulating position, and we can figure out how much pressure this transmission is going to generate at the minimum side of things, the minimum spec. And then the solenoid would just add to that spring force to raise line pressure. So you'd have to overcome not only spring force, but also the solenoid pressure. So I position this valve into what I would think would be the regulating position. You could see that bevel that's on that pressure regulator valve that's separating line pressure in this passage to the bypass, which is in that passage, that you could see it has its way in. Now over here, this bevel here is allowing line pressure to find its way into the bypass pretty easily. I still think that probably this is going to be the regulating position. And dimensionally, I'm getting about 670 thousandths of an inch of that spring. So that spring would be compressed to about 670 thousandths of an inch. And at 670 thousandths of an inch, I'm getting about 2.1 pounds of force on the OE spring. So that's the GM spring, the OE spring. It's got about 2.1 pounds of force at 670 thousandths of an inch in length. And looking at that Sonnax spring, it pretty much outputs about the same pressure. It's at 670 thousandths of an inch, and it's outputting 2.15 pounds of force. So after doing the math and calculating in the 2.15 pounds of force that these springs exert on the end of these valves when they're at 670 thousandths of an inch in length, it would require about 26 psi of line pressure to move this valve over into its regulating position. Now, what we determined by looking at these pressures, that there's very little difference in spring tension between the Sonnax valve and the OE valve, so they're not really trying to change pressures. Although they look completely different, they function pretty much the same. So at this point, we got this valve body together, and it's built well with the upgraded parts as needed. So we're going to go ahead and put our oil pump back in. And the kit does come with replacement gaskets. So when you got this kind of this end gasket that we have, that is a replacement item, and it comes in the kit. In the kits, they also give you two different sized gaskets, so obviously you'd want to use whatever size you have. One's substantially thinner than the other, so you can imagine if you put the thin one on when it requires a thick, you're going to bind these parts up. So anyway, we'll go ahead and replace our pump gasket with the one provided in the kit, and we'll assemble the pump into the valve body. You don't want to forget to place that gutter into its proper spot. Put the pump gasket onto the valve body, and slide the pump into the valve body. So there are two different grade bolts for these oil pumps. If you've got the 9.8 grade bolts, which is what these have, you're only supposed to torque these down to about 90 inch-pounds. But if you have the 10.9 grade bolts, you're supposed to torque them to about 115 inch-pounds. And there is actually a torque sequence that basically is a star pattern. It's a good idea to spin this thing by hand while you're tightening this, make sure you're not binding anything up. At this point, I'll put in the large check ball right here, small check ball right there. This is that 2015 valve body, so we're really, at this point, ready to join the upper to the lower valve body halves. Now these valve body bolts right here get hand tightened at this point, but when we assemble it to the vehicle, it's just going to be tightened to 71 inch-pounds, not very tight at all. When looking at this top plate here, you're going to see two different size holes. You're going to see this smaller hole and a larger hole. Well, the larger hole is going to be the bolts that go all the way through with that external Torx head, that Torx Plus, and the smaller ones are going to take these 8mm bolts that assemble the upper and lower valve body halves together. So that's the way at a glance you can figure out which bolts to put in which holes. Larger holes, don't get one yet because they attach the valve body to the case, and the smaller holes, they're the ones that attach the upper and lower valve bodies together. Okay, now this next step could be a little messy. If you're installing a new valve body, or even one that's been cleaned out and it's dry, there's always a possibility, because of the design of that pump, where those vane rings don't have a ring to keep them pushed out, that when this pump spins, it doesn't suck the fluid into it, and you basically install the valve body, start the vehicle up, and you don't have any prime, you don't have any pull going into your oil pump. So it'd be nice to know that before we put all the stuff in the vehicle. So what I've got is I've got this pan filled with fluid. We're going to go ahead and put this filter on it, and we'll put this all into this pan, and then we're going to drive that pump. See if I could do this without too much spillage. So then what we can do is we can go in and spin this pump with a drill. Now I had to make a little bit of an adapter. Basically it's a round rod and weld a little couple ears on it. And then what that can do is that's going to grab onto our pump sprocket. It's going to drive it. So we put our pump sprocket on. And now what I'm going to do is I'm going to put my raincoat on. Wish I had one right now. Maybe try to keep my gear out of the fluid a little bit. I'm going to spin this up. There it goes. See how fast I had to spin that? This drill spins at almost 2,000 RPM, and I had to go wide open, and then finally started pumping. Now I can actually make it move fluid by hand. So now we know that this pump has the ability to prime, and if we put this in the vehicle, we're not going to have an issue with that. Thank you for watching this video on the valve body overhaul, and if you haven't watched them, I did make a video on the disassembly of this transmission and a video of the reassembly of this transmission with the clutch clearances and the gear set installation. There's also some videos after this that cover the theory of operation, everything from the electronics to the hydraulics to the torque converter operation, modifications, and even rebuilding particulars, a shorter video that just kind of covers some of the small pieces and parts of the rebuild process. So be sure to check those out.